Hey, hi everyone. So today we are back with another video of our continuation to the entire series of system design for restaurant on the Go platform. So in the last video, what we discussed is about how you gonna place the order when you land or when you go to a restaurant or a hotel via scanning the QR code. Now, what we discussed in the last video in detail was we scan the QR code, we land onto the specific menu page for that restaurant, and in that restaurant menu page we add the items to the cart, which all items we want to order and all that stuff. Then we place an order. Now after we place an order, now what will happen is usually there are different verticals that we discussed about in the last video. One is the admin consumer or the admin portal who wants to see the orders coming in. Second is the kitchen attendant who wants to see the kitchen orders coming in the real time when you place an order. Then the third one is the waiter attendant, or I would say the captain attendant, which are there on the restaurant side, on the hotel side. Now, what we want to discuss in this video is, or where we left the last video is, now when you place an order, we need to send out the notification to all these three consumer in different times as well. Now, how these notifications to be sent out, what asynchronous mechanism we should use to send out these notifications to them so that they accept those notifications and take relevant action on them. Now, in this video, we're going to be discussing about different, I would say, not different queue systems, but one of the queue systems. And in the next video, probably we'll compare different queue systems, that why we pick this one and why not this one, so and so. Now, in this video, we'll discuss about Kafka. So, what Kafka will be doing in our system and how we will be integrating the Kafka in our system itself. Now, if you see here, I place an order here. I place an order. Now, that order goes to the backend system. Now, assume this to be a backend system. Okay. Now, this backend system will actually talk to or will actually put data into a queue. Now let's use some other general symbol, or I would not say queue, but a topic. So let's say it is a topic, order topic. Now you place an order, it calls some backend API via some API gateway or whatever. So this API calls the Kafka client. So now this backend API can be written in any of the languages. It can be in Java, Node, Python, Golang, or any of the relevant language that you know of. Now, after that, inside that backend, the code will be integrated to the Kafka client libraries. For example, you want to put the data into the Kafka topic or the order topic. Now, you will integrate some of the client libraries in your relevant coding framework which you are using. So, with that, it will integrate. Now, the second part is now there are multiple restaurants coming in. Now, let's say there are hundreds of restaurants who are actually scanning, where users are scanning the QR code and they are actually placing an order. Now, what actually is happening, the order which is coming into the relevant queue of your, let's say, for example, there is a restaurant A, then there is a restaurant B, and so on. We have some 100 restaurants. Now all those 100 restaurants would be users will be placing an order. So all those orders would be coming here in the topic order. Now if the same orders are flowing from different restaurants to the same topic, so how we gonna segregate them out based on the restaurant where it was placed? So there the major thing that we're gonna be discussing about is, so I'm gonna explain some of these facts over here as well. So first thing is message key. So message key is the one thing which will actually be the distinguishing factor that for which restaurant this order is. For example, you placed an order for restaurant one. So message key for that restaurant will be some XYZ or something special message key for that restaurant, for example, or some restaurant ID for that field. Then you would have another restaurant that is restaurant two, which would have let's say some other code 123 or so on. So they will have their own. So each restaurant so on will have its own key, which which the backend libraries will integrate and pass on the message key while integrating to the Kafka topic. Now, what happens inside Kafka topic when we send these different restaurant IDs in the message queue? Now, basically, in Kafka, there are partitions in a topic. So I'm not going into detail of Kafka, what is Kafka and how to integrate. I'll make a separate video of it by doing a practical hands-on session as well. So where I'll explain what are partitions, what are brokers, what are cluster, and what is topic and all that, what are streams and all that stuff. But in this video, we'll be keeping it short with respect to our design. Now each topic will be part of separate partitions. So let's say when you create a topic, you specify that you want these many partitions. You want, let's say, six partition or seven partition or whatever. Now, based on your restaurant IDs, let's say you have 100 restaurant IDs and you want to divide them in multiple partitions. Okay, and you are seeing that out of these seven or eight restaurants, or let's say 100 restaurants, you have these 10-20 restaurants which are receiving high number of orders. So you would have the separate partition or probably have 2-3 partitions for them, so that whenever the orders come in the large number, so then you would have a scalable factor in your architecture as well. Now, how these partitions comes into play and why I am explaining about partitions after the message key. Now, whatever message key you send in the in your backend code for invoking the Kafka topic, so that message key, what Kafka will do is it will hash that message key and it will put that message itself in a specific partition based on the hash function. So let's say there is partition 1, then partition 2, then partition 3, then partition 4, and partition 5. So let's say these are some of the partitions you have done. Now, when you sent restaurant ID 1 message, it went into partition 2. When you sent restaurant ID 2 message, it went to some other partition. So on. So all those 100 restaurants, whenever the message comes, so those will be part of different partitions. So those all messages for all those 100 restaurants won't flow into one partition itself. That is the use of partition. Now, Kafka has inbuilt different mechanisms for maintaining your architecture in a scalable way, and resiliency also is maintained there inside it by different practices, which we will discuss in detail. But I'll just highlight few of them here. So one is the partition, which actually scales your message which are coming in. Like you must have heard about that Kafka can scale to trillions or billions of message or whatever. So partition is one of the area where Kafka basically scales your number of messages which are coming in. Now, secondly, resiliency factor is very important when you have large number of orders coming on, large number of messages coming into your queue or topic. So what you have to do is, so basically you have to be resilient enough, or your architecture should be resilient enough that in case of any failure, it should be able to withstand to that load. So that's where the replication factor of Kafka architecture comes into play. Replication factor says that, let's say, if you have replication factor 2 or 3 or whatever, so then those many, I would say, the partitions would be replicated onto different broker machines. Now broker machines are nothing but where you have, let's say, you have one topic and you have 5 partitions. Okay, so you need to define the brokers. Let's say 3 brokers you define. Okay, now those 3 brokers would divide those 5 partitions amongst them. So if you have, let's say, you created broker 1. Broker is nothing but the Kafka, I would say, machine which you can assume of, and let's say you have 5 partitions. Okay, so now if I'll try and put the 5 partitions here, so this is my first partition. So I need to divide these 5 partitions in 3 brokers. Okay, so what I'll do is I'll put these 2 here, and then third one here, and then so on. I'll put fourth one also here if I have 3 brokers. Of course, if I have more brokers, so then I can put brokers, or sorry, partitions in those different brokers also. So this way, this is your broker machine. Now each broker machine has at least one partition, and some brokers have more than one also. Now the replication factor, it says that, so how many replicas of your partition you have. So if the replication factor is 2, so then you would actually create at least 2 copies of your one partition. So let's say this is partition 1 and the replication factor is 2. So then you would create at least two copies of your partition 1. Now, best point is you put those partition 1 in one broker and partition one's copy or the replication factor in another broker, so that whenever broker 1 goes down, so your entire partition 1 should not go down. At least uh, what we have is in the second broker we have partition 1 already available, which is up and running, so we can redirect the traffic to partition 1 which is in the second broker. So that's where the resiliency matters whenever you are dealing with production based application and so much of load is coming in and the application has to be highly available and all that stuff. So that's where your replication factor is pretty important when you are discussing about these terms like brokers, partitions, replication factors, messages, key, and all that stuff. So this is brief about very brief about the Kafka internal system, how it works. Of course, there are a lot of in-depth activities or a lot of in-depth knowledge which we need to have based on different use cases that we can put in place for the Kafka cluster use cases. So we will discuss those in detail in a separate video also. So I'll remove this stuff for now. So now what happens is we put the uh, order, or I would say the order event in a topic. Now from that topic you would be subscribing to different consumers. Now there will be like admin consumer that we discussed about, kitchen consumer and all that stuff. Now all those consumers will be listening to these topics that we have, or the messages which are coming in these topics. Now based on that, what will happen is, so let's say the firstly you place an order. Now firstly it has to go to admin and wait kitchen attendant. So those consumers will be listening to these kitchen or I would say order topic. Now here comes the another factor which is consumer group. Now consumer group is, now here admin is one consumer and kitchen attendant is another consumer. So they are separate consumer groups. Okay. Now each of those consumer groups will have multiple consumers inside it like C1, C2 and C3 and whatever it is. Okay. So this is let's say admin consumer and this is let's say kitchen consumer. Now these are consumer groups. Now consumer groups are basically nothing but a separate, I would say, services or I would say separate business functionalities which you want to integrate. You can understand in that terms. So it's not like if you have multiple machines listening to a topic or multiple cloud functions listening to a topic. So those are multiple consumer groups. No, it's different business functionalities or different services which you want to integrate to a specific topic. Now, in this case, we want to integrate admin functionalities and kitchen functionalities to this topic separately. Now, both these are separate consumers. Both these have their own management application, for example. So, in this case, so both these consumer will listen to this topic, and both these consumer will actually get all the messages which are coming in. So, if let's say you assume that admin has read order topic, so they have read message ID 1, it doesn't mean that kitchen attendant will not be able to read it. Kitchen attendant also wants to read that information, so that's why they are part of a separate consumer group itself, so that both these consumer groups can listen to all the messages which are coming into this order topic and they can relevantly process it. Okay, so that's in brief about the underlying architecture of how it works on basis of Kafka. So we will discuss in detail about these topics in our next video. We will further extend our, I would say, from here on itself, that how after placing an order what all things or what all consumers comes into play, and we will discuss about data processing also in our further videos. So those also will be coming in, and yeah, so that this entire series is going to be very interesting going forward. I hope you like the videos that we are presenting to you. Please like and share if you like the videos or you like the content, or if you have any suggestions, please add a comment for upcoming videos so that we can incorporate them. And if you want to subscribe the channel, or if you like the content and you want to view the latest upcoming videos, you can subscribe to our channel and press the bell icon. and you can refer this channel to your friends or whosoever needs, and they can also subscribe to the channel. Thank you. Bye.